What if a cat could somehow be both alive and dead at the same time? It sounds impossible. Yet this famous thought experiment was created by physicist Erwin Schrödinger in 1935 to demonstrate just how strange quantum mechanics can become. Even today, physicists still debate what the experiment ultimately tells us about reality. In the early 20th century, scientists discovered that nature at the atomic scale did not follow the familiar rules of classical physics. Light sometimes behaved like a wave and sometimes like a particle. Electrons also behaved in unexpected ways. To explain this strange experimental result, physicists developed a new theory called quantum mechanics. Erwin Schrödinger was one of the founders of quantum mechanics, but he was deeply troubled by some of its implications. According to one interpretation of the theory, a quantum state can exist in multiple possible states until it is measured or observed. Schrödinger created his famous cat experiment to show how strange this idea becomes when applied to everyday objects. Schrödinger imagined placing a cat inside a sealed box along with a radioactive atom, a detector, and a poison mechanism. If the radioactive atom decays, the detector triggers the poison and the cat dies. If no decay occurs, the poison is never released and the cat remains alive. Until the box is opened, we do not know which outcome has occurred. According to one interpretation of quantum mechanics, the radioactive atom exists in a superposition of states until it is observed. In other words, the atom is both decayed and undecayed at the same time. Since the cat's fate depends on the atom, the cat itself would also exist in a strange combination of states, both alive and dead, until the box is opened. This leads to one of the deepest mysteries in modern physics, known as the measurement problem. When exactly does a quantum system stop existing in multiple states and settle into one definite outcome? Does observation itself affect reality? Physicists still debate these questions, and there is still no universal agreement on the answer. Over the years, physicists have proposed several different interpretations of quantum mechanics. Some believe the wave function collapses during observation, while others suggest that every possible outcome actually occurs in separate, parallel universes. Although the mathematics of quantum mechanics works extremely well, scientists disagree about what the theory ultimately means. Schrödinger's cat remains one of the most famous thought experiments in science because it challenges our everyday understanding of reality. Quantum mechanics successfully explains countless experiments and powers technologies such as lasers, semiconductors, and quantum computers. Yet, even after nearly a century, the deep meaning of quantum theory remains one of the greatest mysteries in physics. Thank you for watching.